Hi, everyone. Welcome to this session about Cloud Native with Spring Boot and Kubernetes. I'm really excited to be here at J4K. Thanks for joining. I'm Thomas Vitale. I work as a senior software engineer at Systematic, a Danish software company. I'm really passionate about Spring, working with Spring and with cloud native technologies. I'm also writing a book about this subject. It's called Cloud Native Spring in Action with Spring Boot and Kubernetes. It's published by Manning, and right now it's available in early access. Today, I'd like to go on a journey with you, a journey in less than 30 minutes from development to production. It's going to be a cloud native journey. We're going to start with building a simple cloud native application using Spring Boot, great framework focused on productivity, on simplicity, and on developer experience. We're going to build a simple web application. And when we're ready, we're gonna containerize it. So we're gonna package it as a container image. And to do that, we're gonna use Cloud Native Buildpacks, which is a specification to convert application source code to a container image. It's a project hosted at the CNCF, and we're gonna see how to use it with Spring Boot applications. Then once we have a container image, we're gonna deploy to a Kubernetes cluster, and we're gonna see several little details that we need to consider in order to actually deploy the application in the best possible way when we run on Kubernetes. So without further ado, let's get started. And the first stop will be start.spring.io. That's where we're gonna initialize a new Spring Boot application. I will create a new Gradle project with Java. I want to use Spring Boot 2.6, the latest milestone available. And the application will be called demo service, like that. Also, I want to use the latest and greatest Java 17. That's nice. Now, the application will be very simple from a business logic perspective. It will expose an HTTP endpoint. It's a web application, so as a dependency, I'm gonna add Spring Web. I have two options. One is the traditional servlet-based stack, for example, using Tomcat and Spring MVC, and the other one is a Spring Reactive Web. With the reactive stack in Spring, we can build applications which are more resilient, more scalable, and more efficient because they consume resources in a more efficient way compared to servlet-based application. So I'm going to choose a Spring Reactive Web because one of the goals of going cloud native is exactly about resilience, scalability, and cost optimization. Next, since our journey will end in production, I want to add also Springboot Actuator, which is a great library that out of the box provides several endpoints to monitor and manage the application in production. For example, it exposes information regarding the health of the application or even the metrics. And for example, if I want to expose metrics in a specific format like Prometheus, I can add that dependency as well. This is it for our demo application. Now I can generate the project and open it in my IDE. I have already done that, so let's move to Intellij Idea now. Okay, this is the entry point of our Spring Boot application. The first thing I want to do here is creating a REST controller. Let's call it demo controller. And in here, I want to define a method to handle GET request to the root endpoint of the application. The return type will be a string, so I want to return a message to the user. And since we are using reactive Spring, I'm going to use one of the reactive types, in this case, mono or string. Mono means 0 or 1 value. So you can think of like the optional object, which can contain either no value or 1 value, but it's a publisher, it's a reactive publisher here. The other type is flux, that is for multiple values. So monostring, get message. And in order to build a mono, I can use mono.just and pass a message like Spring Boot to the cloud. This is fine, it works, but probably when I deploy this application on different environments, I might want to change the content of this message. So having it hard-coded inside the Java code is not nice. We want to externalize the configuration. In particular, we want to be able to have the same package, the same artifact from our application deployed on different environments. And then from the outside, we want to be able to change the configuration. So the first step to do that is creating a new custom property. So I'll open the application YAML file and define a new property called demo message. Springboot to the cloud. This one will be the default value for the property. This file is packaged with the application. Then when we deploy the application, we can override it through different ways, through environment variables, system properties, or even through Kubernetes config maps, which we'll see in a minute. Once we have the property defined, let me do that. Yes. We'll go back to the Java code, and we need a way now to parse this value. The recommended way is using Java Bean. I'm on Java 17. I can use regors. The regors are perfect for this type of usage. So I'll define a regor to name demo properties. We'll have only one field of type string called message. And then I need to tell Springboot that this regor is meant to be used as a configuration properties bean. So I'll use the configuration properties annotation, but not just any properties, but only the properties with the prefix demo. So this demo message property will be parsed into this record. One last thing that I have to do is enabling the functionality in the application. So I can say configuration property scan. So now Springboot will scan this record and will parse the property value from the application property file. And this is it. Now that we have the bean, we can inject it in the demo controller and get rid of the hard-coded value. So I can say private final demo properties. I'll use constructor injection. And then instead of having the string here, I call demo properties message. That's it for our implementation. So it's a really simple application. Now that we have the functionality, since we want to go to production and we want to ensure the quality of our application, it's important to write some auto tests. So I'll move to this other class, which is generated from Spring Initializer when I create a new project. Right now it's empty. What I want to do here is set up a context to run integration test. To do that, I'll use the Springboot test annotation. And since this is a web application, I want to have a full web environment set up and for random port, because I don't really care in the test which port is used by the server. Then I can write a test case. For example, we can test that when we send a GET request to the root endpoint, then we return the message. To send the request, I'll auto-wire here the web test client utility, which is really convenient to send HTTP requests to the application I'm testing, and defining some assertions, so to verify that the result is correct. So I'll say web test client. I want to send a GET request to the root endpoint, so just slash, and then with exchange, I send the request. And then I expect the status of the response to be 200 OK, and the body to be parsable into a string class, into a string object here, equal to Springboot to the cloud, which is the default value we have in the property file. That's it for our test. Now I can run it. So once again, we use web test client to send a GET request to the root endpoint. Exchange will send the request, and then we can write assertions about the response, in particular the status, that is OK, and the body. We want to get the message that we defined previously. And it looks like the test is green, so our functionality works. The next step is packaging it and deploying it. Cloud native applications are supposed to be self-contained, so we don't want to have external dependencies. The only external dependency that we allow is the runtime. In this case, is the Java runtime, but everything else should be packaged together with the application. And that is the default mode that we have in Spring Boot, which is the jar packaging. So what I can do from the terminal window now is calling the Gradle task called boot jar. If you use Maven, there's a similar task to run. And now the result is a jar file, also called a fat jar or a uber jar, which contains all the dependencies that the application needs to run. So at this point, I can run it just any other standard Java application. I can say java-jar and then point to the path where the jar file has been generated by Gradle. And this should be the path. Perfect. In this other window now, I'm going to use a little utility called HTTP. It's really convenient to send a GET request to my local host on port 8080, which is the port used by default in Spring Boot, and then the root endpoint. And I get the message back. So we know that it's working. That's great. I'll stop the application now. And if I'm if I want to deploy the application on platforms supporting jar files directly, I'm actually done. So for example, I can take this jar file now and deploy it on Heroku, and I have my application in production. But I'd like to make it even more portable, because the jar file is convenient when we deal only with Java applications. But containerizing the application, then we have one uniform way of handling different workloads independently from the language or the framework that we are using. And using the Spring Boot plugin, both for Gradle and Maven, it's really easy. I can just run another task. So previously I ran bootjar. Now I run boot build image. And with this task, I'm going to obtain a container image. So what happens under the hood is that Spring Boot is using cloud native build packs. So if we go to the browser now, cloud native build packs is a specification to transform your code into a container image. It's a specification. There are several implementations. In particular, Spring Boot by default is using the Paketo build packs implementation. And this approach is not just for Java applications. You can use it also in other languages. But in particular, for us, it's really nice that we can use the same approach to build both standard JVM applications, like I'm doing now, but also GraalVM native images. So the task is, is done. So I get this container image back. And at this point, I'm ready to take this container image and deploy it on a Kubernetes cluster. Behind the scenes, I have all this code pushed to GitHub, so you can actually check it out from there. I want to show you that I have a continuous delivery pipeline there that is packaging my application and pushing it to a container registry. I'm using GitHub Actions. So let's check the workflows here. I want to show you what I'm doing. We have two steps. The first step, I run Gradle build, which compiles and run all the tests for my application. And if this step is successful, then what I do next is using that same task, boot build image, to both containerize the application and directly publish the image to a container registry by using this -- publish image argument. I can also specify a different image name, like I did here, and then the credentials to access the container registry. So my image now is already on Docker Hub, and I'm ready to deploy to Kubernetes. So Kubernetes, I have a cluster that I installed on Azure using the new VMware Tanzu Community Edition project. It's open source and free, so you can try that out. And part of the platform that I'm running, I have Knative. Knative, you can see it's a Kubernetes-based platform to deploy and manage modern serverless workloads. So for me as a developer, it provides a higher level abstraction on top of Kubernetes, which makes it easy to write deployment manifests. So it's less verbose, it's less commands, and also it adds serverless capabilities. So for example, it allows to scale to 0 applications. So think about functions and other serverless applications. To visualize my cluster, I use Octant, which runs locally. So you can see that right now we don't have any pod, so there's no application running. For development purpose, since now I have the image, but I still don't know if it runs correctly, I can use the Knative command line. So I'll open a terminal window here. This is the Knative command line. I can say service create. the service name will be demo service. And then I'll point to the image that my continuous delivery pipeline pushed to the registry. That is Thomas Vitale, demo service, J4K 1.0. That's it. Now, Knative, you can see under the hood, is creating a deployment, a pod, a replica set, service, and also is configuring an ingress controller for me. So I get back this URL that I can take and directly use it to send HTTP requests. And I get a message back, Springboot to the cloud. Again, this is really convenient when we are in a development phase to test the application, but in production, we need something more because there are different aspects of this application now that are not quite okay for a production usage. For example, I have this pod now. If I delete it, then Kubernetes will shut it down immediately and create a new one. But if there was any request in progress on that application, then the user would get an error. But we don't like that. We want to ensure resilience and have a zero downtime experience for our users. Now, I trigger it manually, but that is what happens when, for example, we do a rolling upgrade or when we scale in and out the application. The other aspect is that Kubernetes doesn't know when the application is ready to accept new requests. So you can see this ready option here. Right now, by default, when the container is started, Kubernetes assumes that it's ready to accept requests. But that's not true, because when we start it up, it can take a couple of seconds to actually start up. So if we send a request, the request will be dropped because the application is not ready to process it. And also, if the application is overloaded, maybe it's momentarily unable to process the request. So there are a lot of different things that we need to consider. And as you can see now, since for more than 1 minute, I didn't send any request to the application, Knative is scaling the application to 0. So if there's no request to handle, then there's no reason to keep a pod alive. But as soon as I send the request, a new pod is started. And here is the next problem. You can see that I'm kept waiting because the application takes a few seconds to start. So that's another aspect that we want to fix. So what I'm going to do now is deleting what I have created right now from the command line, and we'll do something better, something more suitable for a production usage. So I'll go back to my editor, and I'll start doing some live coding on YAML. Let's see how that goes. I have a service file here, service YAML file. So we have a service object. This is from a custom resource from Knative. It's called service, but it's not the same as the Kubernetes service. But it comes from serving Knative dev v1. Then we want to have the name to be demo service. And then we have the spec. And the containers. So we have one container for our application. Let's name it demo service once again, and then the image, the same that I used from the command line. So it's demo service J4K and 1.0. So at this point, the result would be the same as from the command line, but it's not enough for production. So first things first, I want to define CPU and memory for the container. So I'll add a resources section. I have two types of resources that I can define in Kubernetes, request and limits. The requests are the minimum guaranteed resources to a container. The limits are, the upper limits. Let's start with memory. I'll define both request and limit. I'll use the same value because it provides better performance for the JVM. Memory is a non-compressible resource. So when the limit is hit, then the application is killed with an out-of-memory error. So you want to pay attention to that. We really don't like those kind of errors. Instead, the CPU, let's say 0.1, the CPU is a compressible resource. If we hit the limit, if there's not enough CPU cycles for our application, then the process is throttled. So we might have some, not nice performance, but the application is not killed. I'm not defining the limits for the CPU in order to get a boost during the startup time. So this is an option that you can have. Yes, we have the resources in place. So this is already better than the previous example. But still, we have all those little aspects that are not taken care of. For example, when we shut down the application or when the application is running, how to tell Kubernetes about the internal state of the application. So one thing that we can do is configuring Springboot to shut down in a graceful way. And to do that, I'll define a config map. The config map is, let's call it demo service. And I can take an application property file from Springboot and embed it in a config map. So I can say application YAML and then write all the properties in here. So same syntax as in Springboot. So I have server and then shut down graceful, for example, so that the server, when it receives a termination signal, it doesn't stop right away. It will just stop accepting new requests, but then it will spend a few seconds in order to process all the ones that are still in progress. And we can define that period of time, that waiting time is called grace period. So we can say Spring life cycle timeout per shutdown phase. So for example, 15 seconds, that's good. And since we are configuring from the outside the application, that's where the externalized configuration principle that I talked about earlier, we can even override the value for our own message. So I can say demo message, Springboot on Knative. Yes. Now with this config map, I can pass the values to the Springboot application in a few different ways. What I'm gonna choose to do is defining a volume out of the config map. So we'll have a new volume, let's call it demo volume, from a config map, the config map that we just created, that is called demo service. And then I mount this volume into the containers. So I'll say volume mounts. The volume is called demo volume, and the mount path will be /workspace/config. Since I created the image with build packs, I know that the Springboot application will be placed in this workspace folder. Also, I know that Springboot by default looks for a configuration properties file in the same path where is located and in subfolders called /config. So I know that Springboot will read the configuration that I put there, but I can choose any other path. If I do that, then I need to explicitly tell Springboot where to find it. In that case, I would use the Spring config import property in order to point to the exact path where to find the configuration. But we'll go with the config folder. Yes. That's good. We have graceful shutdown. We have CPU and memory configuration in place. We even overridden the value for our custom property via the config map. One last thing that still we need to do is finding a way to tell Kubernetes about the internal state of the application. So we have two types of information that Kubernetes can process and act upon. One of the features of Kubernetes is the self-healing property, so that if something goes wrong, then Kubernetes by itself, through controllers, will take care of fixing the situation for us. But we need to help it a bit. And we'll do that in two ways. The first thing we want to do is informing Kubernetes about the liveness state of the application. An application, if it's not alive, means that it entered a faulty state from which it can't recover by itself. So what Kubernetes does is stopping that pod and starting a new one or restarting the same pod. And the information can be passed through what is called a liveness probe. Now, if you remember, I have added Springboot Actuator in my project. And as a matter of fact, Actuator makes sure that when the application is run on Kubernetes, that the application exposes information about the liveness state through a dedicated endpoint. So I can tell Kubernetes to send an HTTP GET request to this path /actuator/health/liveness. It's configured and enabled automatically when we run Spring Boot on Kubernetes. The other information is about the readiness state, called a readiness probe. When an application is not ready, it means that it can't process any more requests. So what Kubernetes does is stops sending traffic to that specific instance until it's ready again. And we have a dedicated endpoint for that as well, provided by Actuator. So /actuator/health/readiness. And then we also can configure an initial delay for checking that. So initial delay is seconds, maybe 15, and period seconds, 5 for both of them. I think we are good to go. So I'll open my terminal now and use the Kubernetes CLI to apply those manifests. So Kubernetes apply, we point to the Knative folder. Let's see if I wrote everything correctly. There's a parsing error, line 20. Yes, that space. It's so fun writing in YAML. Another error. Yes, that's containers. This is fun. Great, now we have the application. So in order to get the URL back, I will use the Knative command line once again. So I'll say kn service ls, and I'll get the URL. So we can see the application is not quite ready yet. So let's check in Octant. You can see that at the beginning it wasn't ready because the readiness probe was not returning a 200 OK message. Now it's OK, so I can call it from the browser, and I get the new message, Spring Boot on Knative. And if you're curious about Actuator, liveness returns 200 status up because the application is alive, and readiness up. There is one last thing that we haven't quite fixed. I'm using Knative, so I have the possibility of running serverless applications, and in particular applications for which I enable scaling to 0. So if there is no request for the application, I don't want to keep it running and consume resources without reasons. But if we look at the pod and the starting time, let's check the logs and the demo service container. In this specific cluster, it took 3.8 seconds to start, and that's too much. If I'm a user and I visit this endpoint, I don't want to wait that much to get a response back. So what we can do is using Spring Native. So if you remember in our original project that I have still here, if I add a dependency on Spring Native, then I will get a Spring Boot application compiled to a native executable using GraalVM. So just by adding that dependency and keeping the project as it is, I have pushed a new image, which is called demo native, that now we can try and see how is it different. So what I'll do is removing the existing workload. And instead of using the demo service application, I'll use the demo native one. Let's also update the rest. Yes, config map. We can even update the config map, so we know that it's a different one, Spring Boot, Spring Native on Knative. And now I apply the changes. So what happens now is that we get a different image. It's not running on the Java virtual machine. It's a native executable packaged still by Cloud Native build packs. So you can generate the image in the same exact way, but since we have Spring Native in the class path inside the project, then we get a native image. Let's open it. So first we can native, let's see if it works. Returns Spring Native on Knative, that's nice. And then if we check the logs, we can see that on this specific cluster, it started in 0.1 seconds. So we have now a good framework to also build and run serverless applications with Spring. And that was our journey there. We went from development, so we use Spring Boot. We also briefly mentioned Spring Native to build native executables. We containerized the application with Cloud Native build packs. It's the same approach both for JVM images and native images. And then we deployed it on Kubernetes. In particular, we used Knative, but all the things that I mentioned are true similarly on plain Kubernetes. We still need to consider all those aspects. Thank you very much for joining this session. Now I'm available to answer a few questions, and if you still have more that I can't answer now, feel free to reach out on Twitter or LinkedIn and to keep writing on Whova. I will check it later and reply there if we don't have time now. Thank you.
You have some questions, Thomas, in your chat. You want me to read them for you, or can you access them?
Yes, I can read them. So what's the best way to do integration testing in Spring Boot? So I mentioned briefly the integration test with the Spring Boot test annotation, but an integration test is expensive because it starts up a full Spring context. So what I recommend doing is distinguishing between the different types of testing. So if, for example, your test is focused on testing only on a specific slice of the application, like the data layer or the web layer, then you can use, they're called slice test in Spring Boot. So instead of using the Spring Boot annotation, you can use a different one specific to the layer you want to test. For example, I can show you briefly. So if I want to test just the web layer, I could use the web flux test annotation here and be specific that I want to test the demo controller. So in that case, Spring Boot will only start a context containing just the beans in that layer. That's an option. Regarding testing against external services like backend services like databases, I really recommend test containers. It's fully integrated in Spring Boot. It's such a great tool, and you can use it in your integration test. So you can test against the actual database or the actual backend service that you're using in production. So you ensure environment parity throughout all the stages of your software delivery pipeline. Then we have another question. Let's see. What are the best ways to optimize Spring Boot applications to run on Kubernetes? So Spring Boot by default.
1 minute. You have 1 minute to answer this question. Sorry.
Yes. So Spring Boot integrates natively with Kubernetes, as I showed. It depends on what you mean by optimizing. But for example, if you're looking for optimizing the resource consumption and to have a faster startup phase, then you can use Spring Native. And regarding other aspects, I think if you build a cloud native application and think about all those principles like the 12 factors, then you'll be ready and optimized to run on Kubernetes. Things like externalized configuration, stateless applications, and standalone applications and stuff like that. But if you write more details in the chat, I can reply later and be more specific, depending on what you mean by optimizing. Regarding the other question, so Spring Native, you can find on GitHub the project. I used the same exact application that I implemented during this presentation, but I added the Spring Native dependency in the project, and then that worked out of the box because Spring Native takes care of compiling natively all the Spring libraries.
Your time is up.
I think we are done. Yes.
Yes.
So thank you and enjoy the rest of the conference. Bye.